Nothing there. Okay, so there's data.txt. So let's cat data.txt. See what we found. Oh my God. What the fuck? Control C, Control C, Control C. Oh my God. This is awful. I got it to stop. Okay, so holy shit. Back on Bandit, over the wire Bandit. And where we left off last time was level 6 getting to level 7. And so now we've got the password to level 7. And looking at over the wire, Bandit has 33 levels. This is gonna, I guess it makes up for a lot of videos, right? We get a lot of content out of this. There you go. So that's whatever. Okay, so the goal for level 7 into level 8, the password for the next level is stored in the file data.txt next to the word millionth. I'm sorry, what now? So in the file data.txt, I'm guessing there's a word in it, and the word is millionth. Interesting. Okay, so we're in bandit.level 7. Let's see what we can find, right? So ls, first data.txt. But as we learned from the last video, I am doing a long listing, and I'm going to show the hidden files because I learned the hard way last time. And there was nothing there. Okay, so there's data.txt. So let's cat data.txt, see what we found. Oh my God. What the fuck? Control C, Control C, Control C. Oh my God. This is awful. I got it to stop. Okay, so holy shit. That was insane. We're not even 5 minutes in the video and I'm already cussing up a storm. All right, so we're not going to cap that again. So we have a few different options here. There are two commands that you can use. One is called head and one is called tails, just for information. So in the Linux environment, a lot of different things are basically all text files, like configuration files, scripts, tons of different things are all text based, right? So when we want to edit them, when we want to reconfigure things, we are going into a text document. When we have to do digital forensics, we're using log files. And as previously stated, we have to be able to look at things in an efficient manner, because in our last video, we saw that I went through every single directory and still didn't find the file, and then found a very efficient, quick, faster way to do it. So there's a command called head, and head basically by default, head by default shows you the first 10 lines of a file, right? And then there's tails, and tails shows you the, wait, is it tail? It's tail. Ignore me, tail. There we go. And tail shows you the last 10 words of the file. So that's great. Now we can edit that. We can do dash, I think it's dash n and then 20. And that argument shows you like the first 20 lines. So you can choose the certain number of lines. So in this type of instance, I like to look at the beginning and the end, the heads and tails of the file, just to see if the word millionth is in there. And is it the word millionth? Yes, it is the word millionth. Okay. So yeah, I don't see millionth in here at all. So we're going to clear this out. I need to click into the freaking window. Come on, Red. All right. So our other option is what's known as grep. Now, grep is something that when you're working in Linux, grep is going to become your best friend of all time ever. Grep is a It's essentially like a search functionality. So it allows you to search for specific things in the file, and you can search for strings, you can search for values, you can use grep with what's called regular expressions. So the asterisk, the star, that means kind of like all encompassing. So if I were to grep a file and do star.txt, that means it would find everything in the file that ends with .txt. So anything that comes before .txt in that star section. So what we're going to do is we're going to pipe this into grep. So we're going to cat it again, data.txt. But this time we're going to pipe it. So piping in Linux means that, and we've done this before, but basically I'm putting in input right now, cat data.txt. So when we put an input, I need to learn to fucking talk. When we put in input, the standard out, std out, which is the output, is what just blew up all over our screen, which was awful. That was ridiculous. I couldn't get it to stop. So what we want to do is we want to take the output, which would be the cat data.txt, and we want to pipe it into another other command. I need to learn to talk, which is grep. And in grep, we're going to look for the word millionth. So basically what this saying is cat data.txt. So give us everything that's in data.txt and print it here, but take the print and then put it through to the command grep to look for the word millionth. And then once that's done, it's supposed to just give us the final output. Okay. Right there. So this is millionth, and this is the password to get to level 8. And as you can see, we have our notes text file, and I am putting this for level 8. All right, so level 8 to 9. The password for the next level is stored in the file data.txt again, and is the only line of text that occurs only once. Yes. Okay. So something here, there's a command called unique. And remember, we can use Google or we can use the manual page for these commands. But basically, what this means is that there's going to be a data.txt and it's going to have multiple lines in it. And a lot of those lines are going to be repeating. But the only thing that won't be repeated, that is a unique line, a unique string in the text file, that is going to be that's going to be the password to get to level 9. All right, we're rolling through it. So we're going to go to the manual page for unique. Okay, you can also Google stuff. But unique basically takes the input, right? Writes it to output. And it says here matching lines are merged to the first occurrence. Okay, well, we want just that one line that only is unique, right? So there's got to be something in here that tells us that we can print the lines that are not duplicated. See right here, like dash capital D for the argument, that prints all duplicate lines. So let's find right here, dash U. So we can put it through the command unique and do dash U only print unique lines when we cat it. So let's try that just in case. Data.txt. Okay. So we're going to cat data.txt, and just like piping that we did in the last one, we're going to put it through unique dash Q. I'm sorry, what? Did I miss something? Dash U. Why did I put dash Q? That was weird. All right, so whoops. So we're going to cat data.txt and pipe it into unique dash U. That was weird. Ah, what? No. Okay, so again, you're watching me make all kinds of mistakes. So something I realized is that unique the so you got to look into the way that a lot of these commands work in the background. Unique expects that the repeating lines are going to be next to one another. So unique dash u can get us the unique lines, but we need to sort the data. So we need to use a command called sort. And sort basically, and it's got a lot of different arguments, but sort kind of takes the lines, makes all of them, individual representations and puts them in alphabetical order, right? Because the lines aren't next to each other. So instead, what we can do, if we did sort data.txt, that would kind of like cat, it would print out all the lines of data.txt, but in a sorted order. And then if we put that through unique dash u, so the data gets sorted, then you put it through unique dash u to give us the unique line. Theoretically, this should give us just one line instead of a bunch of lines. Yep, there it is. And so that is going to be our password to get into level 9. Going to put this in our notes app. There we go. Level 9. All right. All right. So level 9 to 10. Password for the next level, again, is stored in data.txt in one of the few human readable strings, which is preceded by several equal sign characters or quote characters. Interesting. Now, of course, it's got commands here that can help us solve this. We know what grep is, we know what sort is, we know what unique is. Very interesting. A human readable string, huh? Okay, so several equal sign characters. I mean, that tells me that several usually means 3, right? So let's just assume it's 3. There is a command called strings, and it's got it right here. So strings is a Linux command that, because there are, plenty of extracted files you'll come across in cybersecurity, whether you're doing an exfiltration of data, when you're doing a pen test, or, doing digital forensics and looking at binary files. There's a command called strings, which it combs through the file and finds human readable, like printable strings. And this tells me that we need to find a printable string. So, and it's got to be preceded by several equal signs, right? So I think our best bet, if we do strings, the command, and then the file, it should print out the human readable strings. But then I think we also need to pipe that through grep with those several equal signs. So let's try that and see if that works. So we're going to do strings, data.txt. We're going to pipe that into grep and do several equal signs. If this doesn't work, I'll look like an idiot. Look at that. Oh, that's funny. So they've got many different lines. The password is, oops, Mondays. There we go. Cute over the wire. Cute. All right. Putting that in our notes. That's the password to get to level 10. Okay. So the password in the next level, again, data.txt, which contains base 64 encoded data. Okay, so the password is base 64 encoded. So we've got, again, commands that you may need to know to solve this level. And one of the first things you'll see is base 64. Well, not first things. One of the things you see down there is the base 64 command, and they even have helpful reading material. So you can go to Wikipedia and read what base 64 is. But essentially, base 64 is encoding. And when a file or a string or data is put through base 64 encoding, it is encoded. It's kind of like a mathematical equation, kind of like a cipher. You can think of it as kind of like encryption. So when it's put through that, you can use the base 64 command to decode certain things. For example, if we go here and go to the manual page for base 64, yep, you can see here you can encode or decode data and then print that data, right? So the decode option is -D, or you can do -- decode. Sometimes it's cool to do that. Whenever you're doing command line arguments for any of your commands, this left-hand side, -D, -I, -W, like those things are the newer version of Linux-based commands. The -- plus the words, that's like the old school, that's the old school Unix, right? Which was kind of like the core to Linux, if you will. So yeah, you can do -- decode. That's fun. We'll do it that way. But let's see what's in here first. Yep, we got data.txt. All right. So let's, in fact, let me just show you if we cat data.txt. Okay, see this right here. This is base 64 encoded. Okay. And usually you can tell, and I've done a lot of different capture the flags. I've competed in the National Cyber League, which is for cybersecurity students, which is an awesome competition. I highly recommend you check it out. But I can usually tell that it's base 64 because it always ends with these two equal signs. So let's just decode this. So we're going to do base 64 -- decode because we're doing things in a really neat way. Data.txt right there. So this string, this data was base 64 encoded. And this is good to know because you will come across encoded, in encoded data, encoded messages, and you'll have to try to put them through a decoder. And this is a great command line terminal way of doing it. There is a really neat online tool. There's tons of online tools you can use. There's even password crackers that are online now instead of having to use hashcat on your terminal. But there's an online tool called CyberChef. I highly recommend you check it out. CyberChef has a bunch of different ciphers and ways of decoding things, base 64, ROT13, things like that. And then you can put this string right here into it, and then it basically, quote unquote, cooks it and decodes it for you. Okay. We're going to do one last one, and that basically gets us a third of the way there, right? Out of 33, 34 levels, something like that. So let's pop one more out. And this one I just looked at, and I can tell you it's already going to be a little complicated. So the password for the next level is stored in the file data.txt, where all the lowercase and all the uppercase A to Z letters have been rotated by 13 positions. I literally just talked about ROT13, and you can even click on it here. And this is a good thing to know. If you click on this here and it goes to Wikipedia, you can see that it's the 13th letter and it next to the alphabet. Now, this is really important, okay, because ROT13 shows you right here the correlating letters. All right, so we've got A correlates to N, and M correlates to Z. Okay. Now, there's a fairly simple way to do this. There's always more than one way to do things, right? So I just mentioned CyberChef. Okay, so this is CyberChef, and I kind of finagled the window so that you can see what it looks like. Otherwise, it's too big. But this is CyberChef, done through the GitHub.io site, and we are specifically interested in ROT13. Okay, so you can go through. These are all the different networking languages, URL things, forensics, some of the favorites. that you can use to decode, or you can just look it up. Rot 13 right here, Rot 13, and we just drag it and drop it. Okay. Rotating the lowercase characters, rotating the uppercase characters, and the amount is 13. So basically we put the input here, click bake, or it's set to auto bake, and it gives us the output, right? So we have the password to get into Bandit 11. So let's log into Bandit 11 through Secure Shell. All right, so we're in Bandit 11. /LAH, just in case it's hidden. It's right there. It's not hidden. And we're going to cat, data.txt. So right there, so all of these have been moved, right? So I'm literally going to copy, and I'm going to go in here and I'm going to paste it. And right there, that's the password. Okay. So you can see it moved all of the letters by 13, and it gave us the password is, and then whatever the password is. Okay. So that is Cyber Chef, and it makes things super easy. However, I also want to show you the command line option. So remember I said that, everything's been positioned by 13. So when you're on the OverTheWire page and it mentions the different commands that may help you, one of the commands it mentions, which you can overlook very easily, is TR. TR is a Linux command that stands for translate. And so you've got, let's look at the manual page for TR. So this is TR, okay? And of course, just like every command, it's got a lot of different options you can use to translate things, and it essentially uses arrays. Now, if you don't know what arrays are kind of like, it's kind of like a book. Like it's kind of like a container that holds information to be used by the command. Okay. So if you look through the manual page, and more importantly, I'll be honest, I think that Google's your best friend, and you can get a lot more information, searching through Google, looking at forums, looking at what other people have posted about how to use different commands quite often compared to just the manual page for all of these commands. So we can pipe the data again into the tr command. All right. So if we cat data.txt and we pipe it into the tr command, what we have to do is give it an array of characters. Now, remember, the characters are uppercase and lowercase, characters. So letters. So we do A through Z, which stands for the uppercase, and A through Z, which stands for the lowercase. Now that's the first array. So this right here is telling the tr command you're going to have letters A through Z capitalized and letters A through Z lowercase, and you've got to work with those, and we need to position them by 13 spots. So we're going to choose a second array and tell it how to position it by 13 spots. Now, the important thing here is that if we go back to the Wikipedia page on Rot 13, which is where I'm at now, it actually shows us that A shifted by 13 positions becomes N, and Z positioned by 13 positions or move becomes M. Now that's really important because we're about to tell the tr command how to position it. So A needs to be positioned to N, and Z needs to be positioned to M. And in our second array, that's where we're going to tell it to do that. So basically, the A to Z is now going to become N to Z, and A to M. And same with the lowercase, N to Z, Z, and A to M. Because remember, it moves 13 positions. All right. And that's our second array. So, and this is what we're telling it to do. We're saying these are the characters you've got. All the N to Z's need to become A to M for the uppercase, and all the N to Z's for the lowercase need to become A to M for the lowercase. Okay. Because it's moving 13 positions based on what we just saw. So if I hit enter, boom, it gives us that. Now, if the command line interface is, confusing on that command, do some research on it to try to understand it. I tried to explain it as best I could. The important thing that I really want to highlight to you is that there's not just one way to do things. Now, these capture the flags, these war games, Bandit is meant to teach you how to use Linux and operate in a Linux environment and use Linux commands. However, when you have tools at your disposal that will make your life easier, it's okay to use them. Because in the real world, when you're doing a pen test, when you're doing digital forensics, when you're doing anything in cybersecurity, analyzing, working in a security operations center, the important thing is not how you got there. The important thing is that the job got done. That's what's important. Okay. So it is okay to use CyberChef. It's okay to use online tools. As you can see, CyberChef was a lot easier to use once we understood that it was ROT 13, positioned or rotated, quote unquote, 13 times as by 13 positions, as opposed to understanding the TR command and researching how to use it. And the manual page didn't really explain it well. And then having to go to Google and research it. So I'm also somebody, if I'm doing a pen test, could I write my own payloads, or could I use a tool like Metasploit, which has a ton of different payloads in there and can make my job a lot easier? I'm going to use Metasploit. That's the important thing, is that the job got done. So I just want to demonstrate that for you and show you that lots of times there are other tools that make our life a lot easier, and we don't have to do every single thing manually. So that's OverTheWire Bandit. We got the password, which will get us into level 12 on our next run through. And yeah, we're going to keep running through it.